Okay, here we go. For Shop Job 2001, we are going to be wiring the PLC for three-phase shop projects. And so in this case, what we're going to do is use the table that I have provided here and the address is specified. So this is the devices table that we're used to, but over here you notice that where we normally would have a symbol, I have the actual address, and that's going to tell us where we're actually going to land our wires for our shop job. So if you notice, the listing here in order is the order, at least on this remote panel, of how they are from the top to bottom. So here's our e-stop 3-position selector switch, 2-position selector switch. This is the normally closed push button, which would normally be red. This is a normally open push button, which is normally green. And this is a normally open push button as well, which is normally yellow. And those are going to be our inputs that we're going to focus on here first. And those inputs come down in this particular panel down to the bottom to our terminal blocks, and then we're going to wire them up into the top. So up here in the top is our inputs for our PLC, and the outputs come out the bottom. Okay, so we're going to focus on the top currently right now. So we'll kind of come back over here, and that's going to be all of these inputs here. Okay, down at the bottom, we'll look at the outputs next. Okay, so there is a little bit of a description for how we're going to strip the wires, what wire, what color we're going to use to wire this up. But in this particular video, we're just going to focus on our hand drawing and how we're going to get that done. Okay, so you can go ahead and read this description, and when we physically wire them up, we'll use those descriptions. Now this is a little snippet that is out of the actual installation manual for the Micrologix 1100, and it shows the inputs for our particular model. So we're using the 1100, but the 1100 has 4 different flavors, and we're using the 24-volt version, which is the BWA version, and the input selection is a little bit different as well. We won't get too much into how some of these differ from others and why there is multiple commons. We just want to basically understand how we're going to wire this up. So what this is a depiction of what you would get if you were using AutoCAD and you pulled in their template for in our case, the Micrologix BWA model number. And I have recreated it in Visio so it could port nicely into a spreadsheet. And we're actually going to jump over, and I'm going to construct in Visio what you would be drawing by hand. So the intent is here you would use your stencil that you were provided, and you would hand draw a wiring diagram that's going to show how you're going to wire your input devices into the PLC. So if you notice at the PLC, we're talking about a horizontal layout there, correct? And even when we come over to the manual, it's depicting that as a horizontal. But then when we're looking at this symbol, it's vertical. Well, the main reason is because we're talking about ladder logic, and we're going to have 24 volts coming in to this particular input, and then we're going to have to complete the circuit by taking the common and putting it to 24 volts negative, and that's going to complete our circuit for us. So that's why this is turned in a vertical fashion so that it works nicely with ladder logic for our ladder diagrams. Okay, so that's kind of how that's laid out. Now when we get into other PLCs, or if we even add extension cards onto our Micrologix 1100 PLC, the actual terminals will be vertical. in this exact layout. It's just by virtue of the fact that we're natively on our PLC that they're horizontal. Once we start stacking cards here off to the right, we will have vertical orientations. Okay. So what I'm going to do is in a Visio file show how you would actually depict your drawing here using your stencil and just pencil and paper. Okay. And this is going to be an activity that you will do on the final, so it's important that we understand it here. Okay, so I'm going to come back up to the table so we know what addresses we're talking about and devices. Okay, and then I'm going to jump over here to Visio, and I have the same graphic for the PLC shown here, and all I have to do is connect my components in. So let's come over here to our devices table, and the very first one is our mushroom head push button. It's going to be our emergency stop, and it is going to go into address 0. Now remember, if we read this out specifically, this right here, the first 0 is the slot number, the second 0 is the word number, and then the third 0 is the bit or the channel in this case. Okay, so we're going to come into channel 0. So let's come back and look at our Visio here, and you see that I have inside the square here, I'm showing the full address of I:0.0/ I actually used 2 places just so they would all line up nicely. On the actual card, it's just going to say I/0 for the input, and then this is just our input 0. So there's a couple different ways that it's labeled there. And I'm going to come over here, and I'm just going to drag my e-stop onto my page here and get it decently lined up. And then we're going to draw some lines here. We're going to take 24 volts and we're going to wire it to pin 1 on our e-stop. And then we're going to take pin 2 or terminal 2 of our e-stop, and we're going to wire it to that particular input. And that's going to bring 24 volts into that particular input. Now, if you remember for the input and output circuitry lesson that we talked about, internal here, there's an optically isolated circuit that's going to sense that control voltage coming in, and but it needs a completed path for us to be able to have some current flow through there. So I'm going to have to take the common here, and I'm going to have to run it over here to the rail for my panel 24 volt negative. Now everything that we're doing here is off of this power supply right here. Okay, there is actually a power supply off to the left here. We'll look at that on the sheet here in just a minute. And you could use that for the inputs only, but it gets to be very cumbersome because some inputs would have to be wired up off the power supply and some would have to be wired up off of the PLC. So I changed that several iterations of the course, and we just run everything off of this power supply now. Okay. And if we come back over here, you'll see that here it'll talk about DC plus and minus, and it says right here that it's DC out. And that DC out means that it is, so the DC out, that's actually a power supply, but it can only be used on these inputs. It can't be used on the outputs, and it can't be used for anything external like our lights or our motor starter or anything like that. Okay. Okay, so back to here. So we have a completed circuit. Now, if you remember from manual motor controls, we're going to want all of these to be blue lines. I'll change these to blue. That's just going to show, because we're going to use 18 gauge blue wire to denote that this is 24 volt inputs. Okay. Okay, so that takes care of this input right here. Okay, so I'm going to go ahead and highlight that off. We've got this one. That one's wired up. Okay. Now for the 3-position selector switch, we actually have, remember, 2 contact blocks on the back side of that selector switch. There's one that's going to be closed when we go to the A position, and there's one that's going to be closed when we go to the B position. So we're going to need to wire both of those up. And so we're going to wire up the first one here. So I'm going to come back to here, and I'm going to pull in a 3-position selector switch. Okay. And I might have to move this out of the way a little bit. And this will help you in your hand drawing too if you watch this video, and you'll kind of know how to place them on the piece of paper. Okay. So then now for drawing purposes, I'm just going to pull this from the rail over because it's going to look nice and neat. When we actually wire this, it's off screen here. I brought one wire down to pin 1 of my e-stop, and then I have jumpers going to all the other inputs down there. I didn't pull 6 or 7 different wires up here to the top for my power supply. But for the convenience of making it look clean here, I'm just going to go ahead and draw my wires coming from the rail. And you could do it either way if you wanted, okay? So I have 24 volts at both terminal 3s of the A position. Notice I have a little A here and a little B there. And then here, I'm going to wire one of those into that input and the other one into the next one down. Okay? And that is going to actually fulfill 2 of these on here. So that's going to fulfill both this one here. That was the first line that I drew in there, and this one here. Okay? So if you notice, they're just kind of going in order. So the 3-position switch is done. Okay? So now the 2-position selector switch will come back over here. And now physically, we only have to wire in 1 contact from the 2-position selector switch. And so I don't believe I have any 2-position in my stencil that doesn't have the second set of contacts in here. Okay, so I've got my 2-position selector switch now, and go ahead and wire this one. On our shop jobs, we showed that if we were in the A position, we were going to be closed. And if we were in the B position, or the second position over here, we were going to be open. And so this is showing that it's closed, and if I flip this over, that would open that up. Okay, so that is that one. That's how we would wire that in there. Okay, so let's go back over here and go ahead and highlight off our 2-position selector switch because it's wired to that 3rd input. Now we're going to get to our push buttons. The red push button, we're going to bring into input number 4. So I'll come back over here, and I need a normally closed push button for that. Bring that over here. Go ahead and wire this up. And then the next one down, well, we'll go ahead and highlight this off. Okay, so this is done. Okay, so then I'm going to do the next 2. The green and the yellow, normally open push buttons. So come back over here and just select my normally open push button. So we've got those 2 done, and now all we need to do is wire in our sets of contacts for our motor starter. And let's come over here, we'll highlight off. So here I tell you that we're going to wire in terminals 13 and 14 for each one of these. So that's important for us labeling. And then, of course, we know that our overload contacts are 97 and 98 for our normally open set of overload contacts. Okay, so I'm going to grab our normally open set of contacts, and we're going to need several of these on here. So let's come and, if you remember, I pointed out this is going to be 13 and this is going to be 14. It's important that we get these correct. And this will be 13 and 14. And this will be 97, 98. Okay. And this is going to be, MS F. It's going to be MS-R, and this will be MS-OL. Okay. Okay. So we've got all of our inputs wired up. We only need, there's actually two commons. This common right here is for the first 4 inputs, and this common here is for the remainder of our inputs. There's a reason why they're separated. These can actually handle faster inputs. If something was going on and off very quickly, these could actually handle them, where these are for slower response inputs. And when you get into PLC and HMI, they should talk about that. So that's all that we need to do for wiring of the inputs for the 3-phase shop jobs. Okay. So now let's come down down on your page over in my setup here, and let's look at our outputs. Okay. So the outputs we learned in the that input-output circuitry are just a set of contacts that close in there, and it's going to take whatever voltage we bring in on the input VAC, VDC terminal for that particular output and send it out to a device. In our case, we are going to be doing all 24 volt wiring. So I'm going to come over here. I'm just going to steal one of these to use over here. So we're just going to, I already have the rails for a 24 volt system set up here for you. And since I am denoting, and I don't know if I've explained this, but see how this has this squiggly line here? That means that it's continued on another page. So it is going to be continued on this next page that we're talking about. And we finished at rung 10 here. So I'm going to go ahead and start with rung 11 here. And then we'll copy this down. Okay, so now we have all of our rung numbers set up, and it'll be easy for us to actually get power into each one of these contacts. Everything's going to be 24 volts, so we're just going to wire everything to the rail here, make drawing it easy. So now we need to focus on our outputs. So let's come back over here. Let's go ahead and highlight off the rest of our stuff here. Okay, so we got all that done, right? So now we're focusing on our outputs. The red and green pilot lights, if you notice, they don't have an address because they are hardwired, and I'm showing right here that they are hardwired. So right here, I'm showing that they're hardwired. So we don't actually need to do anything PLC-wise on that. When we actually get to wiring the panel in class, we'll worry about that. But we're just focusing on the PLC wiring today. Okay, so now the yellow pilot light is going to be our first output. Okay, so we can come back over here and we can pick off a pilot light and place it over here. Okay, and I'm going to go ahead and wire the output to X1, but I still don't have a completed circuit. So just like the inputs, we have to complete the circuit by taking X2 and bringing it over to the rail. Okay, so now we have a completed circuit. Of course, this is our yellow light, so we need to label this as a yellow light. just go ahead and label this as yellow. Okay. All right, so we have our yellow light done. So that's this one. And then we can go to our white and blue lights. Okay, so now we have our white and blue lights on there as well. So the only other two outputs we're going to use are for our motor starters. So let's go back over here, and we have our white and our blue lights done. Is for our three-phase motor starter, but we're just going to need two coils for that. So we're going to come back over here, and we're going to pick out our coil, and this would be A1 and A2 for our motor starter, and then we'll bring this over here. Okay, so we have our coils for our motor starter for forward direction and our motor starter for reverse direction. Now, you may think, oh, well, then we'll just wire these over to the rail. Well, we have two types of protection for an overload that we use on these three-phase controls. One is the normally open set of contacts that we bring into the program that we did in the inputs. And in the program, we're going to ensure that if those close, we are going to turn the motor off in the program. But we also want to use the normally closed set of contacts to ensure, even if something is wrong in the program, that we are going to protect our motor. So we're going to use that other set of contacts here, even though these are wired to the PLC, to protect our motor. And this kind of covers us if we have a problem with our program inside the PLC. So if we haven't taken into account an overload into our programming, at least it will be covered by the hardwire external set of contacts here. So this is just going to be my MS-OL. So now we can come over here and see that those are wired. And I noticed I made a mistake. This would actually be 95 and 96. 97 and 98 are the normally open set of contacts, and 95 and 96 are the normally closed set of contacts. And that is the wiring of the outputs for a three-phase setup. Okay, so how does this apply to this shop job? Normally, you would use these I/O assignments and wire up the devices using these directions, the color and wire size, and even stripping back a certain amount of copper. And this would be after you have drawn them up, and then you would get signed off approval on that. Okay, so when we do this shop job, everybody has the exact same I/O assignments. Okay, when we get to the final, everyone's going to have different I/O assignments. So you're going to get a document very similar to this, but these addresses are going to be changed. So the e-stop may come in at the 4th channel, and the selector switch may come in on 6 and 7, and the terminals come in on 1 and 2. And so one of the reasons we do that is to make sure that the student understands to draw these and to wire them up in an online format. But here's the secondary reason that I like to do this is the fact that it draws out the power of symbols inside the programming software. So we're going to come to RS Logix 500 English, and we're going to look at how to set up a program. So you're going to have to, for the final, give a wiring diagram, very much like this shop job here. So you'll draw it up, and of course you're going to draw it up based on the I/O assignment that you're given, and each individual student will be given different I/O assignments. And then you're going to program a start, stop, jog station, and for a three-phase motor, but you're going to be using those I/O assignments. Okay. So the best thing to do is when you get your I/O assignments and they're different from what you're used to, is come to this address and symbols table here and add in all of your I/O assignments with the symbol names. So we're just going to say that our e-stop is going to come in on the 4th channel. So we want to add a record, and we want to add I:0.0/4, and the symbol for that we are going to call e-stop. Okay, and then for the description we're going to call it okay. Okay, so we're done with that record. And of course you would do that for every one of those. Okay, and then we want to tie this to the e-stop. And we're used to, with all the other shop jobs, the e-stop was a certain address. And if you notice when I do my videos, I type in the address specifically. But you don't have to. You could just type in the word e-stop. And it'll bring in the I/O address. So you don't, once you get your I/O addresses signed up properly, you will be able to use the symbol name for each one of those. And it'll save you from having to continue to reference back to your sheet to get the assignment so you can punch in the address when you're coding. This way you just use the symbol as you're typing it in, and that will ease your pain as far as the address assignments being different. So I hope that helps, and we'll see you in the next video.